Hey everyone! In this last video, I'm going to talk briefly about the last part of the chapter in Imai's book, which outlines some descriptive statistics for single variables. So far, we've been kind of examining averages as the outcome of interest or the quantity of interest when we kind of talked about how certain treatments or interventions affect or what the effect of certain interventions is, right? But of course, it is one possible to consider other statistics of outcomes, not only the averages. And also later on in the semester, we're going to talk about quantifying the uncertainty around our estimated treatment effects. And in order for that, we also need additional measures of kind of not only the center or the center of a distribution or the mean of a distribution, but we also have to kind of quantify the spread of given distributions. Okay. So in the last part of the chapter in Imai's book, there's a brief overview of some of these statistics, and I just want to talk about them really quickly. Um, so, so on the one hand, as I mentioned, we have different measures to kind of capture or quantify the center of our data. Okay, and we talked about the mean already, which is just the average across all observations right here, where xi is the value of our outcome variable or any type of variable for observation I, and we sum them all up and divide them by n. That's the basic average to compute the mean. There are other measures of centrality. Specifically, one measure we often see is the median, which is basically basically the value of the observation where 50% of the data has a smaller value and 50% of the data has a larger value. Minus one observation, obviously. Okay, so the way we can kind of specify this formally is if we index these values kind of in an ascending or descending order. If n, the number of observations, is odd, then the median is equal to x at the index n plus 1 divided by 2. So that means, suppose we have 13 observations, and we sort them all in ascending or descending order. Then the middle observation, where 50 or one half is higher and one half is lower, is the index number 13 plus 1 divided by 2, so 14 divided by 2, that's 7. So if we roll them up from 1 through 13, number 7 is right in the center. Okay, so that's up here. And if n is even, then it's a little bit more complicated because there is no center observation, and basically this means we're looking at the average between the observation that is just above 50% and just below 50%, and that is this expression. So suppose we have a data set that just consists of 5 observations with the values 0, 1, 2, 3, and 100. The mean is 21.2, and the median is just equal to 2, because that's the observation where two observations have a lower value, 2 observations have a higher value. Okay, so that's pretty straightforward. Why do we need the median, and why can't we just rely on the mean? In general, the median, as you can already see in this example, is more robust to outliers, right? So here we have a very high value, 100, but only 1, and that kind of pulls the mean in one direction. The median itself stays the same, even if this value would, you would increase it to 1,000 or 10,000 or whatever, the median wouldn't change, but the mean would be kind of be increased more and more. So as soon as we're worried about outliers and the effect of outliers, we might be thinking about relying on medians rather than means. But of course, we're not only interested in measuring the center of the data, but we also have to kind of characterize the spread of the data, and there are a couple of different measures for that. We talked about the range, so the difference in, or the minimum value and the maximum value of our variable. Another way to characterize the spread of data is to look at the different types of quantiles. So for example, the 25th percentile is the lower, or otherwise known as the lower quartile, which means that 25% of the data has lower values than that specific value, or the 75th percentile means that 75% of the observations have a lower value than the 75th percentile, right? So obviously the 50th percentile is equal to the median according to the logic that I just outlined. Then based on these quartiles, we can also specify the interquartile range, which is the range that contains 50% of the data. And specifically, that is the difference between the range between the 25th percentile and the 75th percentile, because that obviously contains 50% of the data. Okay. When we're talking about outliers, one common definition of outliers is that they are 1.5 times the IQR, the interquartile range, above the upper quartile or below the lower quartile, right? So, for example, if you are aware of, if you know box plots and how box plots kind of identify outlier observations, that's based on whether they are 1.5. Usually that's defined based on whether they are 1.5 times the IQR, so the interquartile range, above or beyond, below the 25th percentile and the 75th percentile. The last two very important measures of spread of a single variable are the standard deviation, which is basically the root mean square of the deviation from the average. So in other words, on average, how far away are data points from their mean. And it's just the difference between each observation and the average squared, and then summed over all observations and divided by n minus 1. And then we take the square root, and that will basically describe the average deviation from the mean value for any given, or for average observations. And the variance is equal to the standard deviation square. Taking the standard deviation and kind of removing the square root of in this equation, and we have the variance of a variable. We'll talk more about these measures as we go further in the semester and talk about quantifying uncertainty and things like that. But I wanted to kind of bring them up here so you kind of have seen those already if you haven't seen them before. So that's pretty much all for this week. Just a summary for you. If you want to remember one thing or only one thing, then please remember that overall correlation is not necessarily equal to causation. If you want to go a little bit more in detail, remember the fundamental problem of causal inference, and that causal effects, or the definition of causal effects, is always based on this comparison between the factual and the counterfactual, but that the counterfactuals are essentially unobservable. And that's the ultimately the problem in causal inference that we're trying to overcome. And in order to overcome that, we always need assumptions, okay? The solution, or kind of the gold standard solution, is the randomized control trial, because here the treatment and control groups are identical on average, and that means that they're similar in all observed and unobserved characteristics. In these cases, we can look at the difference in the average outcome between the two groups as an estimate of the sample average treatment effect, and this is basically the difference in means estimator as estimate of the sample average treatment effect, right? So the difference in means estimator, this is just a different way of specifying, basically going from here we define this sample average treatment effect based on the potential outcomes for all observations. So that's the average difference in individual treatment effects. So potential outcome for treatment and control group across all observations. And of course, we don't observe all potential outcomes for all observations. We only observe the realized potential outcome in the control group, in the treatment group for some observations, and in the control group for the remaining set of observations. So this difference in means estimator is just the average for all observations that are actually in the treatment group, for which Ti is equal to 1, and we take the average of those observations, of those outcomes, and then we subtract the average of all the outcomes that are in the control group, so where Ti is equal to 0. And that's the difference in means estimator as an estimate of the sample average treatment effect. So that's the summary, and that concludes our videos for this week. I look forward to our Q&A session next week.